All right. So what we're going to do now is we're going to get that whole code, from the original file. We're going to paste it inside our new implementation. There we go. And we're going to do the same for the test set. And then I will actually try not to show you the test set now, but let's get the code. Let's paste that below in a new code cell. And now let's enjoy the results. So what we're going to do is first execute this cell. It's going to take a little while actually, because the step is 0.25, meaning we will get a very, very dense grid, as I've just explained. And therefore, the predict method is applied on each of these dense points of the grid. And that's why there are actually a lot of predictions to compute. And that's why it's taking a little time. But there you go, it's coming. Here we go. So not that long, that's good. We just got the results of the training set. Let's also plot now the results of the test set. And then I will make my comments on the results. All right, so we can just let it run and start by observing and interpreting the results of the training set. All right, so just to recap, you have to understand 4 things in this plot. Is that all the points that you see here, whether they're red or green, are the real customers and their real results in the training set. The green points correspond, of course, to the customers who bought the previous SUVs, and the red points correspond, of course, to the customers who didn't buy any previous SUV. And then the other 2 things to understand is that those colored regions here, this red region and the green region, are the prediction regions. So this region is the region where our model predicts that the customer didn't buy the SUV, and this region is the region where our logistic regression model predicts that the customers bought the previous SUV. And so, in order to figure out where the correct predictions are and the incorrect predictions are, well, the correct predictions are where we have some observation points with the same color as the prediction region, and the incorrect predictions are where we have some observation points with a color that is different than the prediction regions. For example, this customer here, who in reality bought the SUV, corresponding to 1 here, is actually an incorrect prediction because it falls into the wrong region, the red region. And vice versa, this customer here, who in reality didn't buy the SUV because it corresponds to 0, well, it's a wrong prediction because it falls into the green region where customers are predicted to buy the SUV. And then finally, what's the most interesting in all this is the prediction boundary. As you understood, the prediction boundary is the boundary between those 2 prediction regions, the green prediction region and the red prediction region. It is where your classifier separates basically the 2 classes, the class 1 and the class 0. And now you have to understand something very, very important. It is the fact, it is the observation that the prediction curve of the logistic regression model is actually a straight line for one specific reason. It is because the logistic regression model is a linear classifier. For any linear classifier, the prediction boundary or the prediction curve will always be a straight line, in 2 dimensions. In 3 dimensions, it will be a straight plan, okay? So that's what we get for linear classifiers.